class, this is part 3, and then let us try to answer A. Since we are looking for the slope on this equation, we are in fact looking for the implicit differentiation. So let's try to do that. Now, the derivative of x here, we get to realize, is simply 1. And then x times y, we get to realize the derivative of that will be x times y prime plus y. And then derivative of this becomes plus 2 times 2y times y prime, which is equal to 0. Now, here, if you have to solve for y prime, and of course, you would have moved these two onto the other side, negative y minus 1 over. As you factor out y prime on each case, we would have left with 4y right here, and then plus x has been factored out and then divided. So in fact, this essentially is equal to negative y plus 1 over 4y plus x. That will be the expression for the slope for A. Now, second part is write an equation of a line which is tangent to curve. So at this particular point, in order for you to get the equation of the line tangent, we will be needing 3 pieces of information. We'll be needing slope and x coordinate and then y coordinate of those two values. For that, we know that already, which is 2, 1. We just need to find out the slope. What is the slope? Using this expression, negative y was equal to 1 plus 1, and then 4 times 1 plus y was equal to 1 plus 2, since the value of x was equal to 2, then we get negative 2 over 6, which is negative 1/3. That becomes the slope. Knowing that, then we should be able to find out the equation of the line, which is y is equal to, well, we can just write it as y minus 1, which is equal to negative 1/3 x minus 2. There we go. This could have been the answer for number B. Number C, find the coordinate of all other points. So chances are that there may be more than one on this curve with the slope equal to the slope. Since the slope is equal to negative 1/3, let us try to look into this one. To answer part C, negative 1 over 3 must be equal to negative y plus 1 over 4y plus x. Now, since both of them is negative, why don't we just multiply by negative 1 on each side and get something like this? This then now will be equal to 4y plus x. Will be equal to, by cross multiplication, we will get 3y plus 3. Then you will realize that x must be equal to negative y plus 3. Or we can also write it as y must be equal to negative x plus 3 too. Either way would have been okay. Now, then what does that mean? We can put those values in place of the original expression. Since x can be easily substituted, we can try to use this expression. So therefore, originally it was x plus xy. So then we're gonna have, in place of x, we're gonna have negative y plus 3. Plus this is x plus xy. X would have been, once again, negative y plus 3 times y. So I just substitute x up to here, the rest of them simply becomes plus 2y squared equals 6. And let us try to calculate the rest. And here we get negative y plus 3. And here we get negative y squared plus 3y plus 2y squared equals 6. Putting everything onto one side, we realize y squared because of these two, and then plus 2y by combining 3y and negative y, and then 3 and here becomes negative 3 equals to 0. And we realize y must be, by factoring, we get to realize y plus 3, then y minus 1. Then y must be either negative 3 or 1. Now, we talked about y being equal to 1 right here. Then the other point should have been y equals negative 3. So let us try to plug in y being negative 3 and then calculate the rest. But in fact, when y is equal to negative 3, we realize that x must be equal to negative 3 plus 3 from that equation. Then x must be equal to 6. So the coordinate which we are looking for is 6 comma negative 3. That is the answer for number C. Alright, let's move on to the next question. Next question right here. Given the function, as it is given right here, what is the range of the function? Now, in order for us to calculate the range, we need to find the minimum value. Now, in this particular question, we'll try to answer B and C first, and then we're going to go back to A. Let us try to answer, how can this be continuous? In fact, one way for us to look at it is this. This function is continuous, and then this is continuous. In fact, product of the two continuous functions would have been still continuous. So therefore, we realize f of x is continuous for all real numbers. Now, let's try to answer C. For what values of x is the derivative continuous? Now, then many values are quite seemingly okay, except when x equals 1. We might have to just consider x being equal to 1 and then see what happens. So, what happens when x equal to 1? Because of the absolute value, it has it could have some quite interesting expressions. So, one thing that we get to realize is this: then f of x can be written in this way: piecewise function, where 2 times x minus 1, as it is, times x squared, if x is greater than 1, or we can say greater than or equal to 1. But on the other hand, we will have 1 minus x squared if x is less than 1. Let us try to find the derivative of each side and see what happens. Now, then f prime of x. Then, as you can see here, this portion in fact is equal to 2 times x cubed minus x squared. And here we get, this one is 2 x squared minus Oops, I forgot the 2 here. 2x cubed. Now, then our derivative here becomes 6x squared minus 4x when x is greater than or equal to 1. On the other hand, the bottom we get 4 minus 4x minus 6x squared when x is less than 1. Now, is this continuous when x equals 1? That is the question for C. So let us try to answer that first. In order for us to see that, we have to realize the limit of f of x as x approaches 1 should be equal to f of 1. When f is equal to 1, we can use this value, which will be equal to 2. But how about when how about the limit of f of x as x approaches 1? Then in fact, that portion can be written as, what is this? As x approaches 1 from the right. And then the limit of f of x as x approaches 1 from the left. Now, as it approaches from the right, we can just look into this one. We know that to be equal to 1. We know that equal to be 2. But on the other hand, how about from approaching 1 from the left side, which will be right here? We realize that the value would have been equal to negative 2. Therefore, we realize that this value doesn't exist. That means they cannot be equal. Therefore, for what value of x does the derivative? To answer that, f prime of x is continuous. Or negative infinity to 2. But not including 2. So that becomes our answer for C. Alright. How are we going to find out the minimum value now? We don't have much time. So therefore, we're going to try to answer that on the part 4.